All right, good morning, guys. For today's lesson, we're gonna continue on with statistics. Specifically, we're going to learn about another way to visualize the data. So, the last lesson we did was on box and whisker plots, or that was 2 days ago. No, that was 2 lessons ago. So, 2 lessons ago, we had box and whisker plots. The last lesson, we had scatter plots and correlation. And now we're going to learn a third way of how we can represent that data visually. And these are called histograms. Okay, and histograms are very similar to what you guys used to do in middle school, which was bar graphs. You know, graphs that look like bars. Like that's all it was. Nice example. You know, a bar graph would look something like this. All these bars here, no particular shape or order, but something like that with a scale and an axis. So histograms are very similar to this type of graph. So it is, definition wise, a graph of data that groups the data based on intervals, and then it represents that data in each interval by a bar. Okay? And in order to do this, we need to know how many times a data point lies in that interval, right? If we were looking at test scores and I wanted to graph something, how many people got in the 70s on a test, right? Well, let's say that we had 4 students in the 70s, and then I want to see how many in the 80s, right? So maybe like 2 in the 80s. Okay, so this represents our frequency. This number here, the 4 and the 2, because it's how many times the data occurs in the intervals. And this 70 and 80, those are going to be your intervals. Now, think about what interval means. Please remember that this is just an example and it's not very exact, but an interval is between two numbers, okay? So when we actually look at our first example, you will see what I mean. So let's go on to this second page and take a look. Okay, so example number 1. The Fahrenheit temperature readings on April 30th, I don't know why it's backwards, on 30 April mornings, okay, that makes sense, on 30 April mornings in Woodstock, New York are shown below. Using the data, complete the frequency table below and construct a histogram. Okay, so guys, please pause this video now and get down at least the data points, make a little table, and then try and make a sketch of a graph, okay? It doesn't have to be perfect. I know it's a lot, but pause the video and do that now. Okay, now that you've done that, let's actually take a look at how we would do this. The first thing we gotta understand in a histogram, making a histogram, is that we're gonna need, it usually will give us a table here, okay? So it gives us these intervals from 40 to 44, 45 to 49, 50 to 54, and so on. So we're going to look at our set of data that they gave us, and we're just going to put down how many times that occurs in this interval, right? So I'm just going to go in order. So 41, well, that's going to occur in the 40 to 44 range. So I'm going to put a tally. Cross that off. 58, well, that's going to occur in the 55 to 59. Tally. Hold off on the frequency. That's when we're going to put as a number how many tallies we see. 61, well, that's going to occur down here. And I want you guys to do this as well. Just start filling in this table with tallies so that it's full and we have all of the points accounted for. Just be careful when you do it. You don't want to mistakenly put a data point in the wrong spot. And if you are having some issues, just keep watching me and get all this stuff down, okay? They're all pretty even so far, so Doesn't have anything to do with this, just a nice observation. And the reason I'm crossing these out is just because I that's how I keep track of it. Okay, so I got all my data points. I tallied them down. Now count how many of each tally that we have. That's our frequency. So we have 4 here, 5, 4, 8, 7, and 2. And this is going to be our key column that we're going to want to look at when constructing our histogram. Okay, the frequency. It's got nice numbers that we can look at. The tallies, that was only just to see how many frequencies occur in each interval. So, what must you include in a histogram? There are 5 huge things that you must include in a histogram. Number 1, you need a title. You absolutely need a title for your histogram. So, let me label this, temperatures. That's a large font. In April. Actually, let's do temperatures on April mornings because it's kind of specific what this graph is. Okay, so temperatures on April mornings. There's mine. That's my title. Good. Number 2, you gotta label your axes. In other words, what goes on the x-axis, what goes on the y-axis. Okay, so think about how we would have to do that. The 2 axes are definitely going to represent, I will give this to you, they're going to represent interval and frequency. But does the interval go on the x-axis or the y-axis and vice versa? Well, guys, the interval goes on the x-axis because we need to be able to count the frequency going up on the y-axis, okay? So that means that frequency will be on the y-axis. Okay. Step 3, consistent scale. Oh, would you look at that? Every single time we graph anything, we always need a consistent scale. Always, 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 always. You can't just put whatever numbers you want on a graph because that's what matches the data. Okay? That's not consistent. So, let's do this together. Let's make a consistent scale. For the interval, I'm going to have 2, 3, 4, 5, 6 different intervals here, okay? Which means I'm going to use about 2 bars for each one, okay? Maybe 3 bars. Yeah, let's use 3 bars, okay? Now, what I'm going to do is usually we start at 0 here, right? So I can put 0 here, but this little line here stands for, I'm not sure what it stands for, but it looks like a Z, okay? And what that means is that it's jumping to our first, our first number, and it doesn't count as inconsistent. So we're going from 0 to 40 to 44. That's what it's saying. And usually that does not look consistent, but as long as we have that little symbol there, then we're okay. Okay? So 40 to 44. There's my first one. Let's actually look at the last 2 steps. The bars must be the same width, and the bars must touch. In other words, for step 4, bars must be the same width. I used 1, 2, 3 spaces for my bars here, which means I'm going to have to use 3 spaces for my next bar, and then 3 spaces for my next bar, and then 3 spaces for my next bar, and so on and so forth. It needs to be consistent, okay? And the bars must touch. Notice how I didn't skip. I didn't go 1, 2, 3, skip, and then do 1, 2, 3, and then skip. I just did 1, 2, 3, line, 1, 2, 3, line, because this new interval now is going to be 45 to 49. And this is going to be 50 to 54. And this is going to be 55 to 59. And I'm just going down with the intervals, 60 to 64 and 65 to 69. Okay. So I got my interval here. But then I got to do my frequency. Well, again, keep it consistent. It goes all the way up to 8. So what I'm going to do is I'm going to skip a line, and I'm going to do 1. I'm going to skip a line. I'm going to do 2. Skip a line, 3. Skip a line, 4, 5. Notice how I'm keeping it consistent. I didn't skip a line, then do 1, and then skip 2 lines, and then 2, and then skip 1 line and go 3. I kept it consistent going up, okay? So once we have this, guys, it's actually very simple. I look at my interval, my first interval, 40 to 44, and so that means I'm right here, and it occurs 4 times. So I'm going to draw a nice kind of like bar up to 4, connecting it to my 40 to 44, and then going back down. Okay, so that was my first interval frequency. So then I do 45 to 49, and I get 5, which means I go up, 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 starting at 45 to 49. I go to 5, and then I go back down. And then I keep doing this. "55 to 59, I'm going all the way up to 8. So it's all the way up here. Again, guys, I know you don't have a graph like mine. It's not going to look anywhere near as neat as this, but just try your best. We're working with what we got. 7 is here. And then this one only had 2. Okay. Look at that histogram. That is beautiful. I got a title, Temperatures on April Mornings. That's what this is. I got the frequency. How often does it occur? I got the interval. Well, on 4 days in April, the temperature was between 40 and 44 degrees. On 5 days, the temperature was between 45 and 49 degrees, and so on and so forth. Okay? And that is your histogram. If you want to shade it in, you can. Okay, it's not a huge thing, but make it look a little bit better. And that is your histogram, guys. Okay, so get down anything you might didn't get, and let's look at another example. Okay, number 2. The histogram below shows data about scores on an algebra test. All right, so take a look. Going up is our number of students this time, so our frequency again. How often does it occur? And then our interval. So here's our scores. So 51 to 60, 61 to 70, 71 to 80, 81 to 90, and so on. So I want you guys to answer the first question. How many students scored within the 71 to 80 range? Let's see. This is 2. This is 5. This is 8. This is 12. And this is 6. The 71 to 80 range is this one here. So 8 students scored between that range. How many total students took the test? Well, just add up your numbers. 2 plus 5 plus 8 plus 12 plus 6. Right? I believe that's 27 plus 6 is 33 total students took this test. How many students scored at least an 81? At least an 81. Be careful with the words. It's not asking below an 81. It's saying how many of you guys got an 81 or higher on it. So we got to start this one and everything beyond this one. So 12 plus 6. So 18 students got at least an 81, which is good. And then it says, can you determine the highest grade from this histogram? Can we determine the highest grade from looking at this? What do you guys think? Well, the answer is no, we cannot. And the reason is, if we look at what the histogram is telling us, it only tells us how many people scored within certain ranges. It doesn't tell us the highest score. So I know 6 people scored between 91 and 100. All 6 of them could have gotten a 100. All 6 of them could have gotten a 91. All 6 of them could have gotten different scores. I have no idea. Okay? It only gives us intervals. Okay, so histograms are kind of limited in that sense, right? On a scatter plot, we could see exactly what the score was, exactly how many times it happened. But this, where you only use intervals, so we don't have exact scores. And one other thing with histograms, there are 2 types of histograms. The first one we just saw was just a frequency histogram. The second one that we're going to see is what is known as cumulative frequency. And all that means, think of cumulative frequency as our cumulative reviews, right? It refers to the running total. Whenever in class, when we would do our cumulative reviews, our weekly reviews, it was a review of everything we learned to date from previous units, okay? So, it's reviewing everything we already learned, same exact way that cumulative frequency works. Each interval now contains a frequency, which represents that specific interval's count, added to the sum of all the previous intervals. Okay, so it's adding on to everything previously, just like cumulative reviews. So a cumulative frequency histogram will always contain column bars that get increasingly taller as you move to the right. It's going to just keep going up from left to right. Think of these bars as our knowledge of Algebra 1. As the weeks go on, our knowledge just keeps getting higher, okay? So number 3, based off this frequency table below, which shows the scores received by students on a math test, create a cumulative frequency table. So it gives us our interval, our frequencies, and then it says cumulative frequency. Okay. So 3 students got between a 50 and a 59 on the test. But remember, this should look like, if it's a cumulative frequency, it should just increase, keep increasing as we keep going on. So we need to add our previous to the new total. So 5 students got between a 60 and 69, which means that we now have a total of 8 students. So what I did was I took this previous one and added it to my new frequency. So the new cumulative frequency for 70 to 79, I'm taking my previous one and I'm adding it to my new one. So now I'm doing 6 plus 8 to get 14. And then I keep continuing this process. 8 plus 14, I get 22. 22 plus 7, I get 29. And then 1 plus 29, I get 30. So all together, there were 30 students that took this test, and that's our cumulative frequency. Okay? last example. Number 4, the table below shows a cumulative frequency distribution of runners' ages. Okay, so let's see what we got. Age group 20 to 29, 20 to 39, 20 to 49, 20 to 59, 20 to 69. Notice how the 20 did not change in any of those. Right, that should be a pretty big giveaway that this is a cumulative frequency because it just keeps adding on to the previous. So according to the table, how many runners are in their 40s? Walk through the table. The number of runners between ages 20 and 29 is 8. Okay, cool. Now it says the number of runners from ages 20 to 39 is 18. But wait, hold on. This just said between 20 and 29 is 8. Now it's between 20 and 39. So what was the difference? How did I get from 8 to 18? Well, that must mean between ages 30 and 39. How did I get from 8 to 18? Well, I just added 10, right? That means that there's 10 runners between ages 30 and 39. And then between 20 and 49, it went from 18 to 25. How did that happen? Well, that means that between ages 40 and 49, how did I get from 18 to 25? I just added 7. And then from 50 to 59, how did I get from 25 to 31? Well, I added 6. And then 60 to 69, how did I get from 31 to 35? Well, I added 4. But the question's asking how many runners are in their 40s. Right there. Well, look at our table here. It says there's 7 people in their 40s. So that is our answer. A total of 35 people are running, because that's the cumulative frequency, it just kept adding up, but only 7 of those people are in their 40s. Okay? Big difference between a relative frequency, which we saw as this example, and then a cumulative frequency, which just keeps adding up. Okay? And that is your lesson on histograms.